Hello everyone, I am Neeraj Sharma from the team Tinkerers of Tronics. I will be presenting you the project by our team, EyeCan, an eye-controlled intelligent wheelchair for Enginex-2015. So let's start by identifying the problem statement. Now, at least once in your life you would have come across a wheelchair-ridden paralytic patient, and in all probability more than once. The basic cause, the major cause behind the paralysis is spinal cord injury. Now, the reports by WHO are staggering. WHO reports suggest that 0.5 million people suffer from spinal cord injury, and 0.12 million out of them are from India alone. Now, let's see what exactly is the spinal cord injury. We know that there is a bone called vertebrae, also popularly known as the backbone. Now, this vertebrae or the vertebral column is not just to provide support to our body. It is a case which is protecting something very, very delicate called the spinal cord. Now, if I have to explain you in simple words, spinal cord is nothing but a bundle of nerves originating from the brain. Even if I state this in mildest terms, spinal cord almost accounts for all the voluntary and non-voluntary actions of our body. Now, by whatever information I have given you till now, you would realize that any damage or injury to the spinal cord would have catastrophic effects. But the extent of this catastrophe would depend upon the exact region, exact point at which the injury has occurred on the spinal cord. Now, the spinal cord is divided into 4 parts. The biggest impact or the biggest disaster that will happen after a spinal cord injury to the person who suffers from it would be if the injury is on the topmost part, called the cervical part. This causes below neck paralysis, as you can see in the topmost image. Complete body without below the neck doesn't just works. And it is the worst case of spinal cord injury. But this is the worst case. I had not yet told you what's the worst thing about spinal cord injury. Spinal cord injury are incurable. Yes, they can't be cured. Even in 2015, when science have made so much progress, there are a lot of complications in the treatments of spinal cord injuries, and they are treated as very, very risky procedures. The basic causes behind spinal cord injuries are accidental, like you fall from height or you face a car accident. So there are not, you can't take any preventive measures to keep you away from a spinal cord injury. When they happen, they happen. So you can't do much on the preventive part of spinal cord injuries. As I told you, tetraplegia, which is below neck paralysis, so you don't have the general options which other paralytic patients have, that operating normal wheelchairs, because your body below the neck just doesn't work. So you don't have those options. So now I told you the paralysis is incurable and you don't have any options to live your life normally after paralysis, or if not normally, at least to live your life with some basic needs being fulfilled. But if the blindness, which is also incurable disease, have something like Braille script as its solution, paralysis, a below neck paralysis must have some solution. Where is that Braille script solution to paralysis? We believe EyeCan is the solution. Yes, EyeCan, the eye-controlled intelligent wheelchair. In this we use just eyes, just our eyes to maneuver the wheelchair. No use of legs, no use of hands, and no use of chin. I will just introduce you how it works. When the user looks left, the wheelchair turns left. When the user looks right, the wheelchair turns right. And when the user looks first left, then right, then the wheelchair moves in a straight forward motion. And if the user blinks 3 times in a row, means a blink is considered as, we are considering blink as keeping the eyes closed for some even 50 milliseconds will be, and then opening it will be considered as a blink, and if the person blinks 3 times in a row, the wheelchair stops. Now, as interesting as it sounds, let's see what is the actual technology behind it. Now, the technological part of this EyeCan is very challenging. The major challenges that we faced in the hardware design was converting this normal wheelchair into electronic wheelchair, fully fledged electronic wheelchair with all the sensors, and designing this new electronic wheelchair from the normal wheelchair. And the second part, that in the software design, the major problem that we faced was converting the gaze, a very real life signal, into something like maneuvering a wheelchair just by using the gaze. And presently there are no good software options that are available for gaze detection. So in many ways, the idea of gaze detection that we are using is a novel idea, and even in the field of research. So let's understand from the basics what this EyeCan actually does in terms of, if I further be more technical about what I was saying earlier. So basically, we take the video feed from the webcam that is in front of the user's face. Then we send that video to the MATLAB that is running in the laptop that is attached to the wheelchair. Then MATLAB takes the snapshots from that video. It processes those snapshots, and accordingly it determines where the person is looking, whether he's looking left, right, or is he blinking, what he's doing. So after determining that, MATLAB can't directly direct the motors to behave accordingly. Only the Arduino can do it. Arduino is the brain of our project. So Arduino will decide which motor should move and for what time. So MATLAB have to communicate with Arduino to get in touch with the motors. So MATLAB sends a serially communicate with the Arduino to tell it that where the user is actually looking. And in the Arduino we have coded it accordingly. So if the person looks left, the Arduino will make the motors move in such a way that wheelchair turns left. So now let's have a detailed analysis of what I had explained you just now. So obtaining the first step was we had used an HD camera from Logitech to obtain the video of the user's face, and it has an autofocus option which is a must for these kind of real life applications. Then the second step is processing the video on MATLAB. We are not directly processing the video on MATLAB, as I said. We just take the snapshots from that video and process them further. We take snapshot at every 25th frame because it is not possible to process each and every frame, because it will be very time consuming and it's not required actually. So we process every 25th frame. Now what are actually the processing steps? Let's see. In processing, what we do is we convert the RGB into a grayscale image. Means we convert from color to a grayscale image. Then in second part of processing, we improve the contrast of the image for better detection of an eye. And then in third part, we actually single out the eyes, or we separate out the eyes from the rest of the background, so that the background should not interfere with the processing of the eye. So we single out the eyes to be used for processing later, like to tell whether the person is looking left or right. Now the important part, like how are we detecting movement detection? Like means it involves two things. First, detect the gaze where the person is actually looking at, and then to send it to the motors. So let's see. In the movement detection, we first save the features of the eyes. Features of the eyes are the highlighting points of the eye which we had chosen to differentiate the position of the pupil in various frames. And the second thing we do is for movement detection is, and this is the basic principle in the movement detection, that we subtract the two frames. We take the absolute difference, positive difference of the intensities of the two frames, of the two consecutive frames, and then we further need to do some processing before actually predicting where the person is looking at. That processing is just to remove some small areas, small pockets, small pixel areas from the image. And as you can see, the prediction that this will give us, it is a left gaze followed by a right gaze. and now the as here it is written that it moves forward, but it's not a direct procedure. Only the MATLAB knows that it was a left gaze followed by a right gaze, but it can't direct. Sorry for the voice list. I was saying that the MATLAB can't directly order the motors to move. So as I said, as I already told you before, that it should serially communicate with the Arduino, because Arduino only has the power to tell the motors what to do. So we had already coded the Arduino to behave in a particular way. Like if MATLAB tells Arduino that it was a left gaze, the code of the Arduino ensures that the motors are run in such a way that wheelchair takes the left turn. And then the next process which I had already discussed is that MATLAB will send the signal, the voltages to the motors, so that accordingly they behave according to what MATLAB has processed, and they should behave according to what we want. Now the question that we should ask is this efficient? Now we had overcome three major difficulties, three major problems that we had faced in design to make it efficient for daily use, for real-time use in our daily lives. So let's discuss them one by one. The first problem that we faced in design was that the eyes of the people in background, like if a person is moving, if a person on wheelchair is moving, then there will be some people behind him. So that background people's eye may interfere with the processing of MATLAB, because in the video their eyes will be also present. So they may get processed and give out some wrong results, and we don't want that. So to remove this remove this bug, what we did was we set a lower bound on the size of the eye which will be accepted, and this lower bound is such that only the user's eye would be able to pass that bound, and the other eyes that will be in the background will be rejected. So we won't face any problem we won't face any problem even if the persons or there are people standing behind the user using the EyeCan. The other basic risk that we saw was there are chances that person have a weak response or a weak response to the dangers that are in front of him. So he needs some kind of protection, like if he's in front of a flight of stairs and he forgets to blink 3 times, or he's late blinking 3 times, the person may fall on the wheelchair. So to prevent that, we had put sensors for the protection of the user. So what we did was we had put sensors for obstacle avoidance, and we had put sensors for edge detection. For example, if the person is front of flight of stairs, we had used in the front part a IR sensor for edge detection. So if there is an edge, then IR sensor will give the output of 1, and when the output is 1, we had coded in such a way that every other movement, any movement of the wheelchair stops at the very instant whenever this IR sensor gives the output 1. So there is no fear or risks involved in using the EyeCan for the user, the user can absolutely feel safe about EyeCan. The problem we faced was how will the EyeCan behave in low resolution settings, in the low light settings, because the person won't be walking with EyeCan with the bulb in his hand. So he needs something that should work even in low light settings. So we had used for that CH920 HD camera by Logitech, which provides very nice functionalities, and it works pretty well even in low light settings. So we overcame that problem too. Now we should the other question which we need to ask is, which needs of the users does EyeCan actually satisfy? So when a person who can't talk, who can't give a hand gesture, who can't walk, even anything that takes him closer to being independent is something that satisfies his physiological needs. Means this is a wheelchair which makes him more independent, and he can do something by himself. It's a physiological need to walk. It's a physiological need to move from one place to another. So we think we are satisfying his physiological needs by giving him something that he can use to make his life better. Not only physiological need, we also improve upon his self-esteem, because he doesn't feel now dependent upon others, any helper or any attender. He can work all by himself. Like, he feels more empowered. He feels that he can work, and it makes him more powerful from within. So we feel that it also satisfies the self-esteem need of the user. Now, if we had to discuss the maturity level of what we are using in EyeCan, we have used the image processing part. Now, image processing is a very developed field. Image processing is used like in almost many of the fields in the industry and in the research level. So image processing has high maturity level. But what we are actually doing is that gaze detection, gaze marking using image processing. Now, generally this is something which has not been much researched upon. There are hardly 2 research papers on gaze marking, and that too just by using sensors. Nobody has ever exactly tried of gaze detection using image processing. So I think it's a very novel idea which we had worked upon, and presently gaze detection technology has a very low maturity level in actual terms of output. So the thing is, the things which sell in market are not good things will not automatically sell in market. They should be better than what's available. So we had to test that how EyeCan actually works compared to the other wheelchairs that are presently available in the market for paralyzed persons. So the estimated cost that we had of EyeCan is nearly anything between 30,000 to 40,000 if we produce it in bulk. The other options that I was talking about is, one of those options is you use a normal wheelchair and you have a helper. But a wheelchair will cost anything around 15,000, and then full-time helper will cost you around 20,000, and this will per year cost of using such kind of scheme would take you around more than 1 lakhs. So this causes lack of independence. This also causes lack of independence. This also causes lack of privacy, because the person will completely depend upon the helper for all his needs, and he won't be alone for most of the time. Now, in the second option is the chin controlled wheelchair. Now, chin controlled wheelchair, for first thing is, it's not available generally in the developing countries, and even in the countries in which it is available, it is highly expensive. It costs anything between 4 lakh to 5 lakh. And the other thing that about chin controlled wheelchair is, it is used for a paralytic patient. So it's very difficult for him to have extensive muscle movements like the movements of the neck, and it in most of the cases it's very painful. And maneuvering the wheelchair by using neck and by moving your head sideways can be feel very awkward in public places. So the user may be a bit disturbed about this thing too. So now let's analyze what is the actual cost of building a prototype of EyeCan. Now let's see we will discuss all the major components that we are going to use in the EyeCan and see what it rounds up to. So the first thing we are using is the normal wheelchair, which will cost anything around 15,000. And the next thing we are using is a battery, which will cost something around 3,000. And then there are 2 rear motors. These are powerful motors that we are using, and plus 2 normal motors that we'll use for change of direction. It will cost us anything around 5,000. An original model of Arduino will cost us around rupees 2,000. Then we have a HD camera, C920 Logitech camera for around rupees 7,000, which also have autofocus functionality. And so the minimum cost, we also we have not yet included the cost of IR sensors and others, which will make it anything around 35,000. But the minimum estimated cost of this EyeCan is rupees 32,000. But obviously, seeing such a product actually developed into something very useful for the society and for millions of people all over the world, not only India, would be a priceless joy for everyone involved. So this is the basic comparison which I had already discussed, that how EyeCan is just the standout option and the best option, one of the best in every term, in terms of what it provides to us and in terms of how cheap it is. So it's the best option that is presently available in the market. Yes, it costs less than 40,000, and comparing it to other wheelchairs, they don't cater to the needs of all kinds of paralysis. Most of them are useless for the below neck paralysis, and all of them cost anything like in lakhs, and in developing countries they are useless. And I sincerely believe that in field of paralysis, I can be the next big thing. I can be the game changer. It can be something what we feel is braille script for the blindness. I can be that sincere solution to the problem of paralysis. And I would like to end my talk with this, and I would like to thank TCS team from the bottom of my heart, also the campus commune team and the Enginex-2015 team, which gave us the wonderful opportunity to present our ideas, to innovate, and to show our ideas to the world. So thank you all. Thank you.